All right, so it has maximum speed right here, and therefore also it has maximum kinetic energy. And by the way, because it's at its lowest altitude, it has the lowest potential energy. So greatest speed at point A. Next question, greatest velocity. Well, same thing, point A. Why does it have the greatest velocity there? Because gravity has been acting on it for the longest. And it has the strongest force of gravity, therefore it's going to have the greatest velocity at point A. Let's see, greatest momentum. Oh, remember what momentum is? Momentum, I'll just call it MOM, is equal to mass times velocity. Well, its mass is not changing, but its velocity is. Where does it have the most velocity? At point A. So where does it have the most momentum? At point A. Where does it have the greatest kinetic energy? Well, kinetic energy, formula for kinetic energy is 1/2 m, that's a 1/2 there, 1/2 mv squared. Well, the higher the velocity, the higher the kinetic energy. If this is maximum velocity, maximum kinetic energy, go together. So point A. Where does it have the greatest gravitational potential energy? Greatest gravitational potential energy, remember, the higher an object is, the greater its potential energy. Well, that would clearly be at point C. Greatest potential energy. That also happens to be where it has the lowest kinetic energy, the lowest speed. Moving on, how about the greatest total energy? PE plus KE. Kinetic energy plus potential energy. That's a trick question because no place, right? Because the potential energy plus kinetic energy will remain constant. Whatever is lost in the form of potential energy will be gained in kinetic. Whatever is lost in kinetic out here will be gained in potential. The small potential here plus large kinetic here will equal the small kinetic here plus large potential there. The sum of the two remains constant. And how about the greatest angular momentum? Well, angular momentum is also going to remain constant. How about the greatest acceleration? Now this is a little bit tricky. You might look at the diagram and think, well, how do I know where it's accelerating the most? Would it be at point B when it's speeding up? No, this is pretty simple actually. Think back to F equals ma. Where are you going to have the greatest acceleration? The greatest acceleration will be where the force is the greatest. Where is the force the greatest? Where is the force the greatest? At the smallest possible distance. You've got the greatest force here, therefore you've got the greatest acceleration at point A also. But I thought it wasn't speeding up anymore here. True, but this is where it's turning the most tightly. That's the tightest part of its turn. Remember, changing direction is a type of acceleration. We know it has to be accelerating the greatest here because we know the force of gravity is the greatest here because we know the distance from the Earth is the smallest. Small distance, greatest force means greatest acceleration. At that point, mostly in the form of changing direction. Okay, did I ever, I think I did make the point earlier. All right, that is pretty much it, folks. Take advantage of the link I sent you that Sammy provided for us. Thank you, Sammy, again. Of the PowerPoint presentations for each chapter. I sent you the link to that in the email. What else? There was something else. Oh yes, obviously the answers written by Paul Hewitt himself from the teacher's manual. Take a look at those. It would be a good idea before the test to browse through some of the ones that were not assigned. Just because they're not assigned does not mean that they are unimportant. Wow, that's like a triple negative. Just because they are not assigned does not mean that they are not important. So take a look at some of the ones that were not assigned. You might want to browse through some of the problems on page 200 as well. And remember, As I may have mentioned already in the RenWeb comment under the homework tab, that there are other places you can go for some help, like page 197, the summary of terms. Also, on page 197, we have these things called the review questions. I don't assign those, but they're extremely important. Then why don't you assign them? Because you can handle these yourself. If you come across one of these questions and you don't understand it, the concept behind the review questions is you should be able to simply flip back a few pages and say, oh, I see, and be able to answer it. The review questions are basically meant just as a review to make sure that you have read the chapter and understand what you're reading. It's the exercises that I do assign. Those are the ones that are designed to get you thinking more deeply about those concepts. So if there's anything in the review exercises or review questions you can't answer, then go back and reread. If you're not reading the chapter, you are doing yourself a tremendous disservice. Okay, the test is Tuesday. You know what to expect about that. And I suppose my next communication with you will be maybe a reminder tomorrow that the test is coming Tuesday. But your next major communication will be the test being emailed to your parents on Tuesday morning. And that's it. See you later.